One of the most important problems in math that I'm sure you're familiar with is solving equations. So for example, here's a simple equation, x plus 2 equals 4, and just by subtracting 2 from both sides, it implies that x equals 2. Now we've been talking about Boolean expressions, expressions where you have variables or literals that take on the values true or false. And one of the most important problems in computer science is the problem of satisfiability. So, satisfiability of Boolean formulas. And it's simply the following problem. I give you a Boolean expression or a Boolean formula. So x1 or x2 or x3 bar. Remember, that means that x3 is negated. And I ask you, does there exist an assignment to these literals, where you assign true or false to each one of these literals that makes the entire expression true? So for example, this Boolean formula that we have here, x1 or x2 or x3 bar, it is satisfiable because I can just set x1. If x1 equals true, then it follows that x1 or x2 or x3 bar is equivalent to true. Why is that? Well, as soon as we substitute x1 for true, then we know that true or anything is true, and so true or x3 bar is equivalent to true. Okay, so this Boolean formula here that I'll label star is satisfiable. Let me give you an example of a Boolean formula that's not satisfiable. x1 and x1 bar. Now notice, why is this unsatisfiable? If I put true in for x1, then I'm going to have true, but x1 bar will then be false, so I'll have true and false. So this will simplify to false. If I put false in for x1, well then I'll have false and something is always false. So this formula here is an unsatisfiable formula. Let's do another example. Here I've written down a Boolean formula, f of x1, x2, ... through x6, and I've defined it to be the negation of x1 or x2 or x3 ... through x6 and x1. Now this ... just means that x4 and x5 are hidden in there. I just didn't want to write them. It's a shorthand. Same with this ... over here. I didn't want to write x3, x4, x5, and x6. Now what we want to figure out is there an assignment of the values true and false to these literals that makes this formula f simplify to true? Another way to write this more mathematically would be, does there exist, this backwards e really means exists. Whenever you see it, you say there exists. So does there exist an assignment z1 ... z6, so these are all values either true or false. Does there exist an assignment z1 through z6 such that f of z1, z2 through z6 simplifies to true? Right? This is the definition of being satisfiable. This is what it means to be satisfiable. It means there exists an assignment of true-false values such that when you plug in those true-false values into f, your expression simplifies to true. Now, that's the question we're interested in. Now this formula up here is, we want to figure out, is it satisfiable or not? Can we find a satisfying assignment to the literals? Well, how do we do that? Well, one way would be to just sort of do trial and error. So how about assigning x1 to be true, x2 to be true? Well, heck, let's just assign all of them to be true. Let's see what happens. Let's just play around with the problem. Well, if we assign x1 to be true, and x2 to be true, and x3 to be true, and so on and so forth, this inner expression here inside the parentheses will be true. Then we'll negate it, so we'll get false, and anything is going to be false. Okay, so this particular assignment does not work. Does that mean the formula is unsatisfiable? No, it just means that this assignment to the literals didn't work. What if we try x1 equals true, x2 equals true, and this time we'll let x6 be false. Okay, so it's a different assignment. Well, again, we'll have true or true or true or true all the way. I guess x6 will be false, but still, the inner parentheses here, since we're ORing since one of these literals, say x1 takes on the value true, the inner parentheses expression will be true. We'll negate it, we'll get false, and okay, false and anything is false. So at this point I'm starting to suspect, this didn't work, I'm starting to suspect that this formula f is actually unsatisfiable. But how can I prove that to you? Well, one way I could prove to you that the formula is unsatisfiable is to go through every possible assignment of the literals and simplify this expression after substituting every possible assignment to these literals and seeing if there are any of them that causes this formula to simplify to true. If they all cause the formula to simplify to false, then we know that it's unsatisfiable. Well, how can we figure it out from this formula? Well, let's just look at it for a second. Since it's not of this expression and x1, then x1 has to be true, right? If x1 is false up here, then we're going to have something and false, so we'll get false. So therefore, the only way this formula can be satisfiable if x1 is true. So for f to be satisfiable, x1 must be true. We just deduced that, because if it were false, the entire thing would be false. But if x1 is true, it means this inner expression is going to be true, because it will be true or something. Then we'll negate it, and we'll get false. So we'll have false and something else, so it will be false. So, you know, we could write, but if x1 equals true, it implies that not of x1 or ... x6 is false. And so if this expression up here is false, then false and anything is going to be false. So we can conclude, you know, sometimes we'll write 3 dots, that means therefore f is not satisfiable.